Exciting news on the apartment door hack front. I ripped out the janky WebRTC code. I'll leave a link for those of you just finding this video randomly while you're in the bathroom. I created another video a few months ago where I set up an apartment door unlock and voice communication system using WebRTC for the voice communications, and Python and WebSockets and some other stuff for the door unlock. And there's a mess of hardware that goes along with it, but the problem was that it was pretty inconvenient to actually use the WebRTC stuff. When someone pressed the call button downstairs, I would have to quickly find whatever device I had, open the app that would let me talk to the front door through WebRTC, and then I would, sometimes it would work, sometimes it wouldn't. I might have to press a couple times. It also didn't work on the LAN, on mobile network. I had to be attached to the LAN with my mobile device for it to work. Anyway, I explained all that in that video, and this video is just kind of an update to see what's changed since then. I've ditched WebRTC for Asterisks, because everybody needs a PBX to open their front door. That's all I'm saying. Actually, it turned out to be pretty simple. In case anybody was using it, I doubt it highly, but the old code base with the WebRTC stuff is archived in the GitHub under the branch named WebRTC, and the new master has an asterisk only in it. So what I did was I added a call button detection circuit to the thing. Now, in the old way, when somebody pushed the button downstairs, the call button on my front door, I would have to listen to the for the analog ring of the actual button on the phone handset, and then I'd have to scramble to find my phone and press the WebRTC button, all that stuff. Now what happens is when somebody presses the button downstairs, they hear a phone ringtone, it's like it's ringing something, and my phone rings, and as soon as I pick it up, I'm talking to them, which is way better. And it's actually not just set up to talk to one device, it's set up to talk to multiple devices. So I have bazillion friggin' tablets and phones and whatever just laying around, and other people here also have access to the door. So there's like 7 devices, and what happens, it will ring all of them simultaneously, and then the first one who answers, it will stop ringing all the other ones, which is pretty cool. And it's definitely way more reliable, and I can use it on not when my device, when my mobile phone or tablet or whatever happens to not be connected to the LAN. So if somebody presses my call button downstairs, and if I'm in Toledo, it will call me. I'm not sure what I can do for them, but that will happen. So it's got a few drawbacks. I got some pretty minor fiddly network DNS administration stuff that I had to do, which I'll talk about a little in some detail later. And it's probably it's got a larger attack surface, security wise, because of Asterisk, but whatever. So what are we going to do? Well, this thing we see here is the README for the wonderful apartment hack software, which is on GitHub. I will leave a link in the description, but it goes through all this stuff about how to install it, the software and everything. Right now we're going to take a look at the hardware bit of it. Look at that. Who knew Emacs could do that? So in my older video, I explained how all this stuff that's in black works. None of that has changed. All of that is exactly the same. The only thing we did was we added a circuit here. We added a new relay, a 12-volt relay which is connected on the input side. Well, from the handset, it's connected to ground, goes to ground on the from ground number 3 on the handset, goes to ground on the relay, and then the call button, which is labeled B on the handset, goes to VCC on the relay, and then the VCC pin is jumpered to in, such that when the call button is pressed, the relay actuates no matter what. The VCC is the input. And if you'll notice, we're using the Raspberry Pi here. On the other side, it's hooked up. Common is hooked up to ground, and normally open is hooked up to GPIO 16. This is different than our other relay, than our older relay, in as much as this relay, the door unlock relay, was configured to be an output in the sense that the Raspberry Pi wanted to send 5 volts to this relay, and then it would cause this to be shorted between normally open and common on the other side. And there was this pin, the in pin, GPIO 18. Anyway, this relay, the 12 volt relay, is configured to be an input on the Raspberry Pi from the Raspberry Pi side. So 5 volt relay is configured to be an output. Configure the pin that the 5 volt relay is connected to its in is configured to be an output, and in 12 volt one, it's just backwards. There's no input with the GPIO 16 pin is configured to be an input from this relay, and that's why it's wired up this way. And that's about it for the new additions to the hardware. I'll note that the voltage requirement for this, this relay, this call bell signal is 12 volts, and I didn't notice how much current it was sending, but I actually currently have a 5 volt relay there. It works. It's just probably burned the house down at some point, but it does work. So if you're just playing around with it, you don't have to necessarily need to buy a 12 volt relay. If you're just getting it set up, you probably want to get one for production later, so you don't fry everything. But yeah. So really, the worst thing that I think the worst thing that can happen is the relay coil burns up, but that might actually start a fire. So yeah. Anyway, safety third. All right, so that is basically it for the new hardware. Now let's take a look at the software diagram. Oh yeah, baby. Okay, the old system. God, the software was so complicated. It was really complicated. There was this WebRTC thing, which really, there was a CLI program on the Raspberry Pi that acted as a WebRTC client that was missing some features. It was the only one I could really find. It was called WebRTC CLI, and WebRTC itself is pretty cool technology. It's just not as mature as PBX stuff like I've converted it to. This thing uses SIP, SIP, Session Initiation Protocol, between a mobile phone app. I'm happening to use one called Zoiper on my Android, my iOS, and my Linux devices. It's for all of them. It seems to work. I haven't tried it on Windows, but you install an app on the phone here, and then you provide it with some information about what the registrar and which happens to be this Raspberry Pi Asterisk server over here. So the Raspberry Pi gets Asterisk installed on it. It still runs all the old stuff, the Door client, WebSocket stuff, But in addition, it runs an Asterisk server at this point. And this WebSocket between door client, door server, it used to handle both unlock requests and voice requests, but now it just handles unlock requests. It's much simpler now. And this is all the same. This HPS between the mobile phone, just in order to get a button that lets you unlock the door. There also happens to be a button in the app that lets you answer, quote unquote, talk to the front door. But all it is like a link that is like SIP : and then the extension number, and it just opens in Zoiper at that point. And there's no more hang up button anymore in there. So anyway, that's how it is. And the old system was pretty janky, and this one seems, although I've had some pretty strange bugs so far, like phones ringing when they shouldn't, and the wrong phone ringing. I'm sure I'll work it out. But it seems, that being said, it seems to be just much nicer and a better way to do things. So anyway, what else are we going to talk about? What are we doing here? Get it together, man. All right, so I'm going to show the Asterisk configuration just for shits and grins here. Asterisk. When you install Asterisk, by the way, the installation instructions are in this README that's on GitHub. I won't go into it. But when you install Asterisk, it puts all these friggin' config files in here. It is very daunting, right? I mean, just like, wow, where do you start? Well, I managed to find a kindly soul on YouTube who had the simplest possible configuration for SIP in Android, and I just sort of took that and ran. And basically, all you got to do is replace the stock sip.conf with something that looks a lot like this. Oops. Oh no. That's not good. That's my password. Hold on a second. So basically all you got to do, this is a configuration file that is in the breakon3 repository in the configs directory. As an example, you can either replace the Etsy asterisk sip.conf and the Etsy asterisk extensions.conf with the contents that look something like this, these files. So this is generalized. It's not an actual working one. I have my DNS host name here. We'll talk about dynamic DNS in a second. But then you just add numbers here that correspond to physical devices in sip.conf, and I almost have no idea what these options do other than the secret. The secret is the password, and in here I actually have 7 configured, and they're all the same. I just have different passwords on them. And then the other part of this is to configure the extension mapping. And 7001 through 7007 are basically just cut and pastes of each other that answer the phone. They dial out to the extension, and then when the call's over, they hang up. And that's that. And it's the same for every one of these 7000 to 7007. Oops, except that one. Let me change that. But the interesting bit about this is that you can actually set up an extension to dial multiple phones. And this is what I was talking about, where I said every device that is connected to SIP here, all these devices, 7002, 7003, 7004, 7005, 7006, 7007, these are all the devices that actual humans use. 7001 is special. I'll talk about that second. But 7002 through 7007 are devices that have a UI and people pick up with their hands and stuff. And so what happens is when extension 7000 is called, it pages everybody, and the first person who picks up wins. That's how that works. So that just means that whoever happens to be closest to their phone when the thing goes off can answer the door. 7001 is actually a SIP client that lives on the Pi itself, and it is implemented using a CLI program called PJSUA, which is part of the PJSIP project. And I drive that through a Python script. And basically, when the call bell rings, a signal is sent to a program that has the capability to use PJSUA to dial out. And its extension, PJSUA's extension, is 7001. And what it does is when it gets a signal, it just calls 7000. And everybody gets called. It's pretty simple. It's actually a lot simpler than I imagined it would be. You can read the README about how to install the stuff and where to put all these files, but all these config files in here are basically templates that you can use to put in the right places. The minor networking and DNS fiddling that I talked about, you have to set up port forwarding, at least if you're behind a NAT, which almost everybody is. If your Raspberry Pi is behind a NAT, you have to set up port forwarding from the router such that it forwards requests to router ports to the Pi. And I think I have it in here about how to do that. Yeah. So we have to pass port. Oh, that's actually wrong. Real-time editing. We have to pass along port 5065, both UDP and TCP. If somebody asks our router for that port number, we want to pass that request on through to the Pi, which is going to contact our Asterisk server. The default port for SIP is actually 5060. I changed it to 5065 because I noticed there were a bunch of script kiddies hitting my Pi, which, whatever, it's not a big deal, but just annoying. So 5065, it seems to confuse them enough to leave me alone. And then you have to open ports 10,000 through 20,000, which are other SIP ports, SIP media ports, both UDP and TCP. Pass those along to the Pi as well. And that's basically it. Well, your way of doing that will depend on what kind of router you have, obviously. In order for this to work, at least in order for you to be able to use soft phones, like the thing I was talking about, Zoiper, when your phone is not connected to the LAN, you're going to need to add a dynamic DNS service to your router configuration. I happen to use this service called Duck DNS, which I like because it seems to be run by like two dudes, and it's free. It's pretty nice. And it also has, if you go sign up for an account there, it's like a 2-minute process, and then if you go to the top of the page, and there's a link up there, like configuration or something, and it spits out a page that has buttons on it for all sort of popular operating systems, or router operating systems like OpenWRT, and it probably has stuff for Netgear. I don't know, but it had it for mine. Yes, right. Okay, so you may have noticed I elided it. I had the software diagram up. I'll pull it back up again. That I actually have two devices that make up the system. One, the Raspberry Pi, and this other host on the internet. I explained some of this in my last video, but it sort of bears repeating. This is not strictly necessary. I could move all the code that is on this internet host onto the Raspberry Pi. It's a Pi 4, so it's reasonably powerful. I didn't do that because I'm lazy, and it was already set up over here. And also because I noticed that during a call, with only one call active, the Raspberry Pi 4 CPU usage was anywhere from 20 to 40%, which isn't. It's probably fine, and given the task of the UI server over here, this web app, it probably wouldn't make a difference, at all to host it over here. But again, I'm lazy. You may choose to just run all the stuff on the Pi. I would probably recommend it, actually, instead of trying to procure another host unless you have one already. All right, I think I'm going to pause this and maybe try to show you the Zoiper configuration of the actual software. All right. I'm busted for not paying for Nagware. I did pay for it on my phone. There's a premium version, which is worth it because it has a more efficient connectivity polling thing, which saves battery life. But on my Linux box, this is my Linux box with this piece of software on it. I'm still running Nagware. So I'm going to show you my setup on this system. Basically, you need to create an account on your PBX. Remember all those 7,000 numbers that I showed you in the configuration for Asterisk? Well, this is one of them. This one happens to be 7004. If I click that, you'll notice that I've used an internal, my internal IP address, my 192.168.1.x address, to talk to Asterisk. This is the IP address of my Raspberry Pi, and port 5065 is the port that Asterisk runs on. I did this because my desktop never moves. It just sits here. But in reality, for your mobile phones and all your actual mobile devices, you would put in the dynamic, the host name of that you've set up to be the dynamic DNS for your router. So if let's say you said lockit.duckdns.org, something like that, that would be that. I'm gonna leave it. 39. Oops. 192.168.1.139. 65, 7004, and then the password. And that's username 7004. Password is the password that was in the sip.conf in the Asterisk configuration. And that's it. And you see this little green check mark? That means the account is working. And I really don't like how it resizes like that. Do you? No, I don't either. But it works pretty well. I can actually call. I wonder if this will work. If I call the front door. Let's try it. Let's just do it. By the way, this is how you call the front door. You can actually make an outbound call. It usually when you're in normal operations, the front door will call you. But if you want to just call it and hear what's going on, you can. Oh, it's ringing. Actually, everything's ringing. See, I got a bug, man. Definitely got a bug. That's very strange. But it should just call the front door. I'm gonna have to fix that. Yeah. Oh well. Yeah, it's a work in progress, man. It's a work in progress. It should just call the front door, and actually, when I use my mobile phone to do it, it does just call the front door. But I'm too lazy to hold out my freaking camera. I'm not gonna do that. What, are you out of your mind? All right. So anyway, that's how you set up the SIP clients. You install this on your computer, your phone, whatever. The one catch might be that if you actually use Wi-Fi calling, Wi-Fi calling is just SIP, And I don't know what happens if you install Zoiper and you try to use Wi-Fi calling, or if if you just try to call the front door like I just did 7001, whether it would try to go over the public telephone network. That would be bad. I mean, it wouldn't work. But anyway, I haven't tested that because I don't have Wi-Fi calling on my phone. So you're going to have to figure that out yourself. The other one bit that's still busted that I need to fix, well, other than what you just saw, is that I think the Raspberry Pi Wi-Fi antenna is a little too weak for where I have it placed, and I think the Raspberry Pi is actually dropping packets. So Zoiper, when it makes a successful call, will give you a little nag at the end of the call. It says, "Hey, you dropped a bunch of packets, WTF?" And that happens basically for every call I make. Either inbound from the PJ SUA on the Raspberry Pi to my phone, or outbound from my phone to PJ SUA on the Raspberry Pi. And it doesn't matter whether the phone is only connected to the internet, or the Wi-Fi, or only connected to the mobile network, or connected to both. It happens every time. So I think it is. I haven't narrowed it down by using NetPerf or any of that stuff to figure out if my connection between Wi-Fi connection between the Raspberry Pi and my LAN is crap, but I will. And yeah, man. I guess the other thing I have that's kind of fun is I actually have. Let's see here. I will show this if I can switch my window capture. Hold on a second. Stand by. There it is. All right. I have in Bring On Through, I have a wave player inside the scripts here. And this thing just calls A play, which stands for also play. And it'll play a wave file from the Raspberry Pi out the front door speakers. So I have that. I have a little shell script and a cron tab set up to play 4 tranches of waves, one about 8 in the morning, one about 3 in the afternoon, one about 6, one about 11 p.m. And there's a directory full of files on the disk for early, afternoon, evening, and late, and it just plays out the door. I don't hear it, but the people outside sure do. I live in kind of an urban area, so there's a bunch of bars around. I'm sure it'll freak people out. It's fun. I think that's about it. I'm gonna call it. I'm gonna call it a wrap, man. Yeah. Anyway, sorry for the rambling video. If you have any questions, please leave them in the commenty thing, and if you have any suggestions, I'd like to hear them too. And hopefully by the time I release this video, whatever that freaking bug is that you just saw will be fixed. So anyway, thanks a lot. Talk to you soon.